Walk through any medieval town where original timber still stands and you confront, well, an uncomfortable question. Why do beams installed when castles were new still carry loads today, while modern sealants promise protection for only a decade or two? Medieval carpenters did not have polymer science, pressure treatment or factory coatings. What they had was a working understanding of wood as a living material that must breathe, shed water and resist decay at the same time. The method they relied on was not a single product, but a disciplined system centered on pine tar, mineral washes and design choices that prevented moisture from becoming trapped. This approach was sworn by across Europe because it worked under real conditions, and it continues to outperform many modern sealants for the same reason. It cooperates with wood rather than fighting it. The medieval solution worked because it treated rot as a biological problem. Medieval carpenters understood that rot does not begin with rain. It begins when fungi find food, oxygen and stable moisture inside the wood. Modern sealants often fail because they form a hard skin that cracks, traps water, and creates ideal conditions for decay beneath the surface. Medieval methods aimed to deny fungi access while still allowing moisture to escape. This mindset shaped every step, from timber selection to final finishing. Preservation was not an afterthought applied once construction ended. It was part of the build itself. Pine tar was the core treatment that medieval carpenters trusted. Across Scandinavia, the British Isles, and parts of continental Europe, pine tar was the primary wood preservative. Produced by slowly heating resin-rich pine in low-oxygen pits, pine tar yielded a thick dark substance loaded with natural antifungal and water-repelling compounds. Unlike modern sealants, pine tar penetrated deep into the grain rather than forming a brittle surface layer. Carpenters applied pine tar to beams, roof shingles, ship planks, doors and tools. It kept wood flexible, shed water efficiently and prevented cracking in cold climates. Most importantly, it allowed wood to breathe. Moisture could leave the timber after rain, instead of being locked inside. A modern application follows the same principles. Wood must be fully dry before treatment. Pine tar is gently warmed until it flows, then brushed on in thin coats. Multiple applications over several days allow deep absorption. Mixing pine tar with boiled linseed oil improves penetration and curing, a blend used in later medieval and early modern Europe. This treatment remains effective on sheds, barns, fences, and historic restorations. Mineral washes strengthened wood where tar was not suitable. In enclosed spaces or timber frames where tar would stain surfaces, medieval carpenters relied on lime wash and ash-based solutions. Lime, made from burned limestone, created an alkaline coating hostile to fungi and insects. It also reflected light, reduced surface moisture, and allowed airflow through the timber. Lime wash was brushed repeatedly onto beams, especially in barns, cellars and halls where smoke and humidity were constant. Ash-rich water was sometimes used to clean or soak wood before construction, subtly altering the chemistry of the timber itself. Modern builders can apply this knowledge by using lime wash on interior structural wood or in shaded exterior areas. Wood ash mixed with water and strained can be brushed onto unfinished wood to raise surface pH. These methods change the biological environment of the wood rather than sealing it off. Iron and wood chemistry quietly reinforce durability. Medieval carpenters often paired oak and other tannin-rich woods with iron fasteners. When iron oxidizes in contact with tannins, it forms iron tannate, a compound resistant to decay organisms. This reaction darkened the wood but strengthened it against rot. This explains why beams around medieval iron nails often remain solid centuries later. The metal was not a weak point. It was part of the preservation system. A modern equivalent involves using untreated iron hardware with oak or chestnut, or applying iron solutions made from iron scraps soaked in vinegar. When brushed onto tannin-rich wood, the same chemical reaction occurs, increasing resistance to decay without synthetic products. Design choices ensured treatments could succeed. Medieval carpenters never relied on treatments alone. Beams were raised off soil on stone bases. Roofs were steep, shedding rain quickly. Eaves extended far beyond walls. End grain was protected through joinery rather than left exposed. Airflow was always considered. These choices prevented the stable damp conditions fungi require to thrive. Even the best preservative fails if water is allowed to pool or stagnate. Medieval builders understood this instinctively. Anyone building today can apply this by keeping wood out of direct soil contact, allowing ventilation beneath floors, and designing structures that dry rapidly after rain. Modern sealants prioritize short-term appearance and speed of application. They often harden, crack, and fail invisibly. Medieval methods prioritized long-term performance and repairability. Pine tar and lime wash could be renewed without stripping layers or trapping moisture. Maintenance was expected and simple. These methods were not abandoned because they failed. They were abandoned because they did not suit industrial timelines. For restorers, homesteaders, and survival-minded builders, medieval wood preservation offers proven, low-tech solutions that work without fragile supply chains. These methods have already endured centuries of weather, neglect, and use. If this guide strengthened your understanding of historical building wisdom that still outperforms modern shortcuts, subscribe to The Beginning for more deep, practical history that remains relevant today. Share this with anyone who builds, restores, or values craftsmanship meant to last beyond a lifetime. History earns its place when its lessons are put back to work.